Okay, hello. So this is Izewitsky. This is my documentation of my computer science project that I've been doing in my grade 12 computer science course. So what I decided to do was a traffic simulator. I'll give a little quick demonstration as to how the final product kind of turned out. I would have liked to keep on working on it, but I was constrained by time, and that's really it. So I'll show the final thing, then I'll break it down into a whole bunch of different parts as we go along. So, also sorry for the fan noise. I think OBS, the recording software that I'm using right now, is kind of making my computer freak out. So, um, it's not inefficient algorithms. We'll blame it on that for sure. Okay, so let's play. So here we have the roadmap, and it's lagging big time. I'm pretty sure that's just because of OBS and not the fault of my computer program, right? Uh, but you can see all the different cars are going different locations, right? And then they stop, right? You think, oh, why are they stopping? It's because they're actually pathfinding. They're trying to get to uh, a specific location. Like this car here, he's found the destination that he wants to go to, and he stops there, right? Thing is, we have people behind different cars, like this guy and this guy, who are stopped after this guy who has probably found his location that he wants to be at, right? They're stopped in front of people that have found their destination because I have made the cars so that they don't like rear end each other, right? So they're going to be stuck there until the end of time, basically. Um, yeah, I'll give you another demonstration because this is the only outcome here. I have all the different cars starting in random initial positions, right? So I'll give it another run. So we'll stop it, run it, and you can also see here some initialization stuff that I will go into a bit more depth in the future. Okay, so here we have all the different cars. They're interacting with each other again, making sure intersection's clear so they don't crash into each other, right? Some of them are reaching their positions in different spots this time. Before we had a huge like traffic jam over here, but now we only have, I guess, up here. We have some over here, right? So what's really going on here? So I'll show you just with one car. How about that? So the way that you add in extra cars into the scene is really easy, at least for the programmer. There's no like um, user interface, like easy user interface here, but um, it's only one line of code to initialize a car, uh, and, and if you want to change his destination, that's all done in this line right here, right? This is going through all the different cars in the scene and updating them and making sure they're all trying to get to their own specific location, um, which is more or less kind of sort of random at this point. I don't really know like what all the different individuals are doing at every single given point in time, but I can test and see like what's going on here. So we have one car. It's going to be of an image car one, and it's going to start some random road. That's what this here is. It's going to have initial speed, and this is going to go through all the different cars in the scene. So there's only going to be one car. So it's going to try stopping at road 0. I think that's going to be. Okay, so let's give it a run. I think road 0 should be around the bottom left-hand corner. So if he ends there, then we'll know that he's pathfinding correctly. Right, so here's one car. He stops all the different intersections to make sure that it's clear to go. Keeps on going. and bada boom, bada bing. He's gotten to his location that he needs to go to, right? So all these different intersections, except for this one, for some reason, all the inputs are stop sign, right? So you have to stop at every single intersection input, check if the roads are clear, and then proceed to go. This one has been a little bit messed up, and you'll see why in a second. And you'll see that this is actually the fault of the map designer, i.e. me, right? That's actually the map designer's fault and not my computer program's fault. All the different roads that have stop signs on them are colored red here, and there's no possible red colored curve roads. I just didn't have the time to implement that yet. So, okay, anyway, so he stops here. He started like up here or something like that. I'm pretty sure that was the most efficient way to get there. I'm doing a breadth first search of for pathfinding, right? So you have your initial position, your initial road splits off into two different places, and you're going to go through and you're going to search all the different ways to get to this end road, or you're going to search all the different paths until you get to this end road here, and then he's just going to follow that. So the code for that looks like car class here. We'll stop it so then maybe the fan won't go quite as hard. I think it just sped up. Oh well. Pathfinding. Here we are. So this is the entire pathfinding function right here. I actually adapted this from some code I did before on one of our previous assignments in this class, which was trying to find a word distance from blood to tears. That was interesting, but yeah, no, this is basically just a really basic breadth first search. I should probably do a little bit more explanation on how the road network is set up. So if we play it again, the car is going to start in a different place, and you can see that the pathfinding is going to work for a different test case here. Okay, yeah, so he started right in front of it. What are the chances of that, eh? Anyways, so what's happening here is every single road segment, or every single road, right? You think that this is one continuous road. It's really not. There's 1, 2, like 3, 4, 5, 6, 7, 8 different little road segments attached. And every single road segment has the swift equivalent of a pointer to the next road segment in sequence, and every other road segment has a pointer to which road it came before it, right? Or actually an array of roads that came before it, right? Because you have this road here that has 2 roads that came before it. And also if in the other way as well, like let's say that you're at a stop sign or whatever, and you have an array of pointers going to the next roads. You have road number 1, you have road number 2, right? So you're going to have to need an array for that. And with that data structure, that's what makes it possible for my car here to be able to look down the tree of roads, the graph of roads, and actually figure out what's where and how to get to his location, right? So that's that. The other huge part of my program that makes it really easy to get all those roads in place is, well, first what I tried to do is I tried to program in every single road specifically, right? So I said, okay, here's a point on the screen, here's another point on the screen, make a road between those points, okay, and then make another curved road, okay, so I'd have to hard code this all in, and that was a nightmare. I never wanted to do that again. So what I did instead is I thought of a little solution to this, which was, what if I were to create a bitmap image, like so, and then my computer would be able to go through it and figure out what's what. So here is the bitmap image of the road network that we made beforehand. So every single red pixel represents a intersection. Every single green pixel represents a curve in the road. Every single black pixel that has two black pixels above and below, or to the left and right, just represents a straight road segment, right? And every single road segment has two roads in it, a top road here and a bottom road. Or over here you have a rightmost road and a leftmost road, right? Just like how in normal traffic, normal roads in the city, you're going to have a right lane and you're going to have a left lane. One's going to have northbound traffic, one's going to have a southbound traffic, or west and east, or whatever, right? The same goes for the turns and the intersections as well. So let's say that we want to make a little edit here. So right now, we'll look at the road, the whole network of roads again. And we'll see that, yeah, okay, this is what it looks like right here. Let's say that I don't want this part anymore. Okay, I want to get rid of this stupid little thing going on over here. Okay, that's going to be really easy to do. So I'll just pause. I'll go into GIMP here, which is the image manipulation thing that I'm using. You could really use like any kind of program, like Photoshop, Microsoft Paint would even work, right? But I'm on a Mac, and the easiest thing for free that I could get was just GIMP. So as easy as that. I'm going to export it, but before I'm able to run my Swift program again, I'm going to need to run this other executable that's going to take this image, turn it into, break it down into its like elementary like numbers. So it'll start in the bottom left hand corner. It'll say, okay, what's the data for this? So it's blue is 255, its red is 255, and its green is 255. So it finds all the different information of every single pixel. That's what I'm looking for here. So I did that with C++ because Swift is incredibly hard to do any kind of core graphics. Well, from what I found, it was really hard to find any resources that would show how to do any kind of like bitmap manipulation, right? So I had to make a different program with that. And the thing is, I did that already in grade 11, so it really wasn't that hard. I took someone else's code, so that's like all of this stuff here. I don't really know what it does. I could learn what it does pretty easily, I think, but it was pretty horrendous in the beginning. So I came through, I added a little bit of stuff like here, right? This is the file name. I couldn't figure out how to get relative path working for the relative paths working. So anytime that anyone wants to use this code, they're going to have to go into the C++ file, and they're going to have to edit whatever path the roadmap bitmap image is. So what you'd have to do is you'd go into whatever picture manipulation you want. You're going to have to export as, right, roadmap.bmp, and this is the directory, the roadmap processing directory, and this is where you're going to be exporting it to, right here, right? So you just press on export. Yep, replace. Okay, fantastic. It does its thing, and now we go and we run the C++ file. So what the C++ file is going to do is it's going to extract all the pixel information. It gives a little readout of what every single pixel is. You can see there's about 30,000 pixels, or yeah, about 30,000 pixels in the entire scene there. We're not using that quite that many, but you can see here. Let's get to a location. Yeah, okay, here. So here is a black pixel. It's found a black pixel, and it turns, instead of saying that it's 255, 255, 255, it's saying that's 000. Okay. Here's some more stuff. A horizontal line would be a string of 000. Just can't seem to find. Oh yeah, right here. So you see that there's going to be a black road segment right after another black road segment. Here is going to be a turn because you have just green. It's another turn, green. So that part there might be like this part of the road right there. So anyways, what does this do? This takes it and then it'll output it into the documents, right? So it'll take all of this information. It'll take basically all these numbers and it'll just output it into the documents. And that folder would look something like, no, not this one. The process data looks something like this, right? Pretty unreadable for humans. However, it's really easy for Swift now to open that and process that. So that's exactly what it does. Now when we run the Swift program, it's going to take those 255s and it's going to get rid of the top little junction that we saw earlier on. Yeah, there was a junction right there. That's no longer there. Okay. Yeah, the car is still going to pathfind to this road over here. I'm pretty sure. Should be able to do that just fine. Yep. So changing the map doesn't change how difficult it is to pathfind for all these different cars. And in fact, if I wanted to, I could bring back all the different cars again, and it wouldn't be that much of an issue. So we can do that really easily by going back to the game scene, uncommenting out all these different cars, running it, building. Now you'll see here again all the 255s, and you'll see that's just, it's reading the file there, and I have it outputting whatever file or whatever information it's getting. So yeah, these guys are going to keep on going. They're going to keep on pathfinding. Yeah, because there's no stop sign here, you'll see stuff like what this guy just did right there. So he just went right through this car without carrying at all, because this guy is actually on this blue segment of road right here, right? And the thing is, at every single stop sign, each car will stop. It'll look into the intersection, make sure that there's no cars there, and if there are no cars in the intersection, then it'll go. Now this isn't exactly how humans would do it, right? Like let's say I'm a car, I'm stopped here. I'm gonna just check to make sure that, okay, if I'm going straight, I just need to make sure that there's no cars going this way. There's no cars that are coming around like that. There's no cars that are going to go back and forth across my path. I don't really care what cars over here are doing, right? But the thing is, all that different logic would be really, really time consuming to program in, and I just didn't have the time. So it works pretty good as is. I could have improved on that, but like, yeah, just time constraints basically. Okay, so this part here, why is this like wrong? Well, it's because every single intersection, you have a couple different parts to it. You have the input and output stream or roads, right? You have the actual intersection itself with all the curves and stuff. So this in total, if let's say that one road segment, right? Let's say that that's like one unit. It's one intersection is like 1, 2, 3, 4, 5 units by 1, 2, 3, 4, 5 units, right? So if we go over here, it's kind of like, you can kind of see that in pixels. So like one intersection here would take up about this entire area, right? And you kind of need to make sure when you're making your roadmap that you're not going to be having like weird corners or anything going on within this area here. See, that's exactly what is going on here. So there's this 5x5 area that I really shouldn't be touching whenever I'm making an intersection, right? However, I have a corner. See, every single corner here, there's 3 different parts to it, right? There's the input, there's the actual corner, and there's the output, right? And because this corner is kind of like going right into the intersection, it's like canceling it out, or it's canceling out the stop signs and the stuff, and it's kind of a problem, but it also kind of illustrates how another feature in this code works. So every single red square, right, you're going to have an actual intersection, like a four-way intersection in the very beginning, right? And I'll kind of show that by getting rid of a little function that I made. So purge dead ends, right? This is another really, so this is getting into the nitty gritty at this point. Like it really doesn't matter too much anymore. But yeah, if you're interested, just keep on watching, right? So if we get rid of this little function here, what this is, it goes through and it purges all the different dead ends of the intersection, makes the intersection, or makes all the different intersections look like actual like three-way intersections, right? Or else you get a mess like this, right? And you'll see, yeah, so I think the program just crashed. Yeah, you're going to get a lot of that if you don't have that one function there. Like, and that's where this happens here. So really, this road segment, this turning road segment should move down one unit, right? And then after that, you'd have a nice intersection with the actual stop sign and stuff here. But what happens is my program goes through and it sees that, oh, this is actually a dead end, right? Or there's no roads going into it, so we just don't need it anymore. So we're going to purge it, right? That's exactly what happens here. So it looks at these two roads and says, oh, it's not leading anywhere, or there's no roads coming into it. Let's get rid of them. It'll do the same for these roads right here, right? So it'll go through one cycle, it'll get rid of all the outside roads, and then after that, it'll get rid of all the next outside roads. So I'll get rid of these two roads here, and then I'll get rid of these 6 roads here. So the right turning, the left turning, the straight on both sides. And it'll do that for all the different intersections until you have a nice looking map. Here, let's re-enable that. This function right here, it'll connect all the roads. So every single road by itself isn't connected. Like I mentioned beforehand, how every single road has a pointer to the next road, right? And this actually connects the road, so then the data structure can be completed. So every single road can point to the next road that cars can move to, and it can have a pointer from the roads that lead into it. Right? Here we have a little bit of debugging. So the first part is just the file readout. Okay, we're getting some issues here because everything has stopped. It's lagging a wee bit. Also, OBS is not helping. This is the purging function. So you can see that we start off with 300 different road segments, and then we end with like 250 road segments, right? That's the number of cars in the scene. And then we can see what every single car is doing every single frame, right? So every single frame starts with a delta time, and then every single car, if we have debug enabled, which is this global variable right here, then we can see what every single car is doing. Its angle, its speed, its acceleration, its position on like in the scene. So every single car starts off in the same position for the very first frame actually, and then all of a sudden they get moved to their starting roads, right? So you can see then some funky stuff happens with every single car. The car name is actually the image of the car, and all the different images can be found in this little assets folder right here. Right? All the different cars I just took straight from CPG Gray's video on traffic and how to fix traffic. It's a really good video, and that was kind of sort of the inspiration on why I started this project here. I wanted to simulate that, but it's a lot harder than one might think originally. Trying to simulate traffic, like how is that going to go? Yeah, so here you can see the car is actually starting to stop because its acceleration is negative. That's pretty cool. Yeah, and you can see that the log goes on for a very, 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 very long time. and at the end, every car is stopped. So yeah, or they're trying to go, but they just can't. So there's so much more stuff to talk about here. There's so many more cool functions and problems that I had to get over. The thing is, like, at this point, I think you've seen all of the really important things. I'm trying to think, what else could I show? Mm, Not much. I've uploaded the code to GitHub, so if you wanna see all the code for yourself, then you just search up my GitHub name, Apple Pylord, and I have Swift Traffic Simulator because I was trying to make a traffic simulator in Python as well before I started doing this in my actual computer science course on my Mac. So Swift Traffic Simulator, I like did 2 commits like yesterday. Uh, once because once because like I just wanted all the code up there, and then twice because there was a huge bug in which the actual bitmap image was like kind of corrupted. So yeah, so you can get all the code up there. Just remember that you're gonna have to edit the locations of your wherever the cars are or the images are in the C++ file if you ever want to actually run it. Where did it go? Oh, yeah, you're gonna have to change these right here. And other than that, oh yeah, I think you would also have to go into roadmap handler here. You also have to go into man alive. It's a little messy here. So this just points to the documents directory, and you're gonna have to make sure that the outputted text file of whatever the C++ spits out is gonna be in your documents folder, or else this function is not gonna be able to work. Okay, I think that's gonna be all. Thanks for watching. Have a good one. Bye bye.